There are a number of water quality parameters, but some of the most common and most impactful are pH, temperature, dissolved oxygen, and nitrates. pH is a measure of how basic or acidic the water is, and it is a measure of the balance between the positive hydrogen ions and the negative hydroxide ions. These ions are either missing an electron, as in the case of the hydrogen ion, or they have an extra electron, as in the case of the hydroxide ion. pH of water is on the standard scale for pH from 0 to 14. pH numbers from 0 to 7 represent an acid and have an excess of hydroxide ions. pH numbers from 7 to 14 represent a basic solution and have an excess of hydrogen ions. Pure water has an equilibrium of hydrogen ions and hydroxide ions and has a value of 7 on the pH scale. Most fish can tolerate pH values from 5 to 9, but the best waters typically have a pH value between 6.5 and 8.2. The impact of water pH can be increased when in the presence of certain other chemicals. For example, fish can usually tolerate a pH as low as 4.8, but they will die at a pH of 5.5 if there is 0.9 milligrams per liter of iron in the water. Similar things happen when aluminum, lead, or mercury are in an acidic environment. The range of tolerance and the effects of pH are dependent upon the type of fish. For example, most fish eggs will hatch anywhere inside the range of 3.8 to 10.0. However, on the edges of that range, most of the hatched fish are deformed. Most trout can survive a pH range from 4.1 to 9.5, yet most carp will die at a pH of 4.3 after 5 days of exposure. And most fish will actively avoid water with a pH outside of the range of 5.4 to 11.4. The temperature of water has a direct effect on all the life that lives within it, and this is especially true for life that is cold-blooded, such as fish. Each organism has an optimal temperature range, but cold-blooded animals cannot survive below 0 degrees Celsius, and most fish will not survive above 36 degrees Celsius. There are a number of factors that can affect the temperature of water. The color of water impacts the temperature because darker colored waters will absorb more heat. How deep the water is typically has an impact because deeper waters are often colder. It takes more heat to warm up these deep waters. The time of year has an impact on the temperature of water because naturally the water is going to be warmer in the summer months and colder in the winter months. The amount of water also impacts the temperature because more water takes longer to both heat up and to cool down. Another factor that impacts temperature is the temperature of water inputs. This also applies to effluent, which is liquid waste that is dumped into the water system. Some examples of effluent that can increase the temperature of water can include wastewater from factories or even water that has run off through a storm drain from buildings and parking lots. The temperature of water influences different stages of animal life in different ways. For example, rainbow trout will not spawn at temperatures above 8 degrees Celsius, and embryos will die at temperatures above 15 degrees Celsius. At temperatures above 19 degrees Celsius, the growth of rainbow trout will stop, and all rainbow trout will die at temperatures above 24 degrees Celsius. As a comparison, largemouth bass will not spawn at temperatures above 21 degrees Celsius, and embryos will die at temperatures above 27 degrees Celsius. Growth of largemouth bass will stop at temperatures above 32 degrees Celsius, and all largemouth bass will die at temperatures above 34 degrees Celsius. Dissolved oxygen is the amount of oxygen that has been dissolved into the water, and is a great indicator of how healthy a water system is. Oxygen gets into the water through diffusion from the air, through aeration from tumbling water, and as a waste product of photosynthesis. Each type of aquatic animal requires a different amount of dissolved oxygen, and dissolved oxygen is greatly affected by the temperature of the water. As the temperature of the water increases, the amount of dissolved oxygen that the water can hold physically decreases. This means that as the temperature of water increases, it can physically hold less and less dissolved oxygen. The opposite is also true. As the water gets colder, it can hold more and more dissolved oxygen. Research has shown that 4 to 5 parts per million of dissolved oxygen is a minimum level to sustain a healthy fish population. While good fishing populations are most often found in waters with an average dissolved oxygen of 9.0 parts per million, and even the most hardy fish will die when the dissolved oxygen level drops below 3.0 parts per million. Nitrogen can be found in waters in the form of nitrates and nitrites. Nitrates are more common in waterways because of their inclusion in fertilizers that can run off into streams, rivers, and lakes. Nitrates in water leads to an increase in plant and bacterial growth, which can provide food for fish. However, if algae growth is too rapid, it can decrease the amount of dissolved oxygen that is in the water. This leads to a scenario that increases fish stress and can lead to death, and is known as eutrophication. There are additional factors that can influence water health, and as was seen from these examples, they are interrelated and can impact each other.